This is the last group of slides for Chapter 3, the second part of the lecture, and we're still gathering some basic statistical data before we really get into doing statistical work, which is coming. First, let's look at measures of variation. And the question is, how can you measure variability? And there are a number of ways to do that. First is the range, and we're going to talk about how each one of these fits in and what consists of, what data the range consists of, and then how you calculate it. Next would be the variance. Following that would be the standard deviation. Then less used is the coefficient of variation. Chebyshev's theorem is next, probably pronouncing it wrong, and it was one of the original statistical theories, and while we teach it and we go over it at some length, it's really not used very much in statistics today. And what is used is the empirical rule, which is used all of the time, and it's one of the few things that I would strongly recommend you commit to memory because it's going to come up a lot in the calculations that you're going to be making in statistics. So let's take a look at these now individually. The range is the difference between the highest and lowest values in the data set. And normally you can sort the data from smallest to largest, largest to smallest, and then you'll be able to see which is the biggest number and which is the littlest number. And if you subtract the littlest number from the biggest number, you're going to get the range. You can, however, also do the calculation in Excel. And to do that, you're actually doing two calculations. To get the largest number in the data set, you would key into Excel equal max, gives you the maximum number. And then you can get the lowest number by keying in equal min, and then whatever that answer is, you subtract the min from the max, and that's going to give you the range. And from a formula direction, this is what you're looking at. The range is equal to the highest number minus the lowest number. And range is used a lot to help you to understand how spread out the data in the database you're working with is. Two things that are much more important are the variance and the standard deviation. The variance is the average of the squares of the distance each value is from the mean. And that sounds like a mouthful, and it sounds like it's complicated. It really isn't. If you were going to calculate a lot of variances and do it manually, it might take you some time. But fortunately, like so many of these other things, you can use the Excel function for variance by keying in equal VAR and then highlighting the data. Once again, the instructional video will walk you through exactly how you do this. The standard deviation is how spread out your data are. It's calculated as the square root of the variance, which is one way to do it. It's also available much faster and easier by just using the function in Excel equal STDEV, equal standard deviation. And using that, you'll be able to quickly calculate the standard deviation. Before computers and before Excel, in order to get the standard deviation, you had to get the variance, because once you get the variance, you could take the square root of it, and that would be standard deviation. With the advent of Excel, you can just highlight the data, go right into standard deviation and calculate it. It's a number that is used all of the time, and variance many times is just the number you use to get to standard deviation. So what are the uses then of the variance and the standard deviation? Well, first of all, to determine the spread of the data. And second of all, to determine the consistency of a variable. Thirdly, to determine the number of data values that fall within a specified interval in a distribution, which feeds into Chebyshev's theorem. And to a great degree, the variance and especially the standard deviation are used in inferential statistics. The coefficient of variation is found by this formula, and the formula that you're looking at stands for coefficient of variation equals, and in this case, S equals standard deviation, and the X with the line over it stands for the mean, so it's standard deviation divided by the mean times 100, and that's going to give you a number. And what is it used for? It's used to compare standard deviation when the units of the different things that you're looking at are different. Is it used a lot? Well, not all that much, but here's an example. The mean of the number of sales of cars over a 3-month period is 87, and the standard deviation is 5. The mean of the commissions is 5,225, and the standard deviation is 773. And the question is, compare the variations of the two. And so now when you go through and you calculate the variation on sales, you come up with 5.7%. When you come up with commissions, which is really, a different set of numbers, you come up with 14.8. And what does all that mean to you? Well, all it means is that commissions are more variable than sales. And is it good to know? Well, there are instances in statistics where it is helpful information to be able to use. Another measure of variation is what's called the range rule of thumb. And the range rule of thumb approximates the standard deviation. And it's a very simple formula. You calculate the range of a data set, highest minus lowest, and divide by 4. And that's going to give you an estimate, maybe estimate's too strong a word, a guesstimate of what the standard deviation is. And it was helpful before computers were around and in widespread use. Nowadays, it's just as fast, if not faster, to calculate the actual standard deviation. I mentioned to you Chebyshev's theorem earlier, and basically, I'm not going to read you the next, you can read it on your own, but in simple terms, what this is telling you is that in any data set, 2 standard deviations from the mean, you're going to be 75% accurate. All of your numbers are going to fall plus or minus 2 standard deviations. You're going to be 88.89% accurate if you go 3 standard deviations, and you're going to be 93.75% accurate if you go 4 standard deviations. I mentioned to you earlier that's not really used very much anymore, and actually in this course, once we finish this chapter, you're done with Chebyshev. We're going to be going to, let's just take a look at the graph of how it looks. And you can see that in the middle, at where X with the line over it is where the mean is. If you go minus 2 standard deviations, you'll see it minus 2s on the bottom of the graph, and plus 2s, that's telling you that 75% of the data falls within that 2 standard deviations. If you go to 3, it's showing you that it's 88.89, and if you went to 4, it was showing you the 93.75. Okay? So an example of that might be that the mean price of houses in a certain area is 50,000. Standard deviation is 10. Find the price range for which at least 75% of the houses will sell. Well, Chebyshev said that plus or minus 2 standard deviations. If 1 standard deviation is 10,000, then 2 standard deviations is 20. So if we subtract 20,000 from 50, we're going to get 30. And if we add 20,000 to 50, we're going to get 70. And so that's what Chebyshev's theorem is going to say. It's that since 75% of a data set will fall within the two standard deviations of the mean, the calculation tells you how much that is. So that it would be on the low end 30,000, 50,000 minus two standard deviations, and on the high end 50,000 plus. So that 75% of all of the home prices, according to Chebyshev, would fall between 30 and 70,000. And so that's basically what the conclusion would be if you use this theory. The empirical rule, as I mentioned to you, is used all of the time. And it's important for you to know it, to understand it, and recognize when you're being asked questions about it. And what that says is that plus or minus one standard deviation, you're going to find 68% of all of the data. Plus or minus two standard deviations, you're going to have at least 95.44% of the data. And plus or minus three standard deviations, you're going to account for 99.7% of the data. Because at three standard deviations, you get all the way to 99.7. Most statistics books, when they publish tables and other information, only go out to plus or minus three standard deviations. Because being able to be 99.7% accurate is really as much as you could hope for. And so the same graph now that you looked at before for Chebyshev falls into place, and this time it's plus or minus one standard deviation, which is shown on the horizontal axis, plus or minus two standard deviations, and plus or minus three. And that's what the graph would look like. Now we're going to talk about measures of position. You're talking about z-scores, percentiles, quartiles, and outliers, our friend that we looked at before. And so a z-score, or a standard score for a value, is obtained by subtracting the mean from the value and dividing the result by the standard deviation. So what you're looking at here is the manual formula. Z-score equals the fraction, and x is the number you're interested in, minus x with the line over it stands for the mean, divided by the standard deviation. Now, if you were to work this out manually, it's a fairly easy formula, and you would be able to do that. We, however, are going to stick with using Excel to perform these calculations for us. A z-score represents the number of standard deviation a value is above or below the mean. It's a simple concept. The manual formula is shown there, but if you were to use Excel, the formula you would use is equal standardized. When you key in equal standardized, it would ask you for three pieces of information. And what are the three pieces? The x, which is shown in your formula, the mean, which is shown in your formula, and thirdly, the standard deviation. When you enter those three, the number that Excel would return to you is the z value. Percentiles. Percentiles separate the data into 100 equal groups. The Excel function for percentile can produce a different result than the manual formula. That's no big sweat though. You should use the function equal percentile.inc. The other formulas will work, the other suffixes which are shown as Excel functions, but for us to all be coming from the same place and all using INC, we're all going to be generating answers that are consistent with each other. Certainly, you could still use the manual formula, and although your results will be slightly different, what you do get will be acceptable for solving problems in class. A percentile rank for datum, one piece of data, represents the percentage of data values below that item. The Excel function might produce a different result than the manual formula. And again, that's nothing that you need to worry about. Your best bet in solving problems like this is to use the function equal percentile rank dot INC. And as we go through some more information in the course, you'll see some of the other functions produce similar but not exactly the same results using a different suffix than the INC. The results that you get either by doing this manually or using percentile rank INC are both acceptable for the problems that you'll have to solve in this class. Quartiles is another measure of position. Quartiles separate the data into 4 equal groups: quartile 1, quartile 2, quartile 3, and quartile 4. Now, quartile 2 is the same as the median, and we usually refer to quartile 2 as the median, not quartile 2. Not a big deal. And so there is a listing. Now, quartile 1 is equal to percentile 25th percentile, which is 0.25. Quartile 2, which is the median, is the same as the 50th percentile. And quartile 3 is equal to the 75th percentile. Just another way, quartiles are special percentiles. And this is, listing what they are. Quartile 1 is the same as the 25th percentile, quartile 3, 75th percentile. The Excel function you use to solve quartile questions would be equal quartile, and again, INC. Another piece of data that you might use is the interquartile range. And there's a simple formula there. The interquartile range is nothing more than the third quartile minus the first quartile. We talked about what outliers were in the previous set of slides, and you looked at some examples of what they might be. The formula for calculating that would be to calculate first the interquartile range, whatever that is, multiply it by 1.5. Whatever that result is, you would subtract that number from the value of quartile 1 and add that same number to the value of quartile 3. On the low end, any number of the data, any number in the database that was lower than the answer you got would be considered an outlier. And on the other side of the coin, any number that was higher than the formula produced number would be an outlier on the high side. We're not going to do a lot with outliers, but it's important that you understand what they are. Another way that data is analyzed is called a 5-number summary. And lo and behold, it consists of 5 numbers. Big surprise. And in any data set, the numbers that you would be looking for to produce the 5-number summary is the lowest number, the value of the data at quartile 1, the value of the data at the median point, which is quartile 2, the value of the data at quartile 3, and high, the largest number. Those listed in that order make up a 5-number summary. And comparing different data sets, it gives you an idea of what the spread of data might be within the data set. So that's the end now of Chapter 3. We, again, will have individual instructional videos as part of Chapter 3 that will allow you to walk through some sample problems. And you should get familiar with those and raise questions on those that might be causing you a problem one way or the other.